Okay. As per the format we've followed, now we have two responses. And the first response is from Barry Loewer. Barry's a philosopher at Rutgers. He's the chair of the philosophy department and director of the Rutgers Center for Philosophy of Sciences. His areas of interest are philosophy of mind, metaphysics, epistemology, history of philosophy, philosophical logic. And he's especially known for his work on mental causation, the metaphysics of laws and chance, and the interpretation of quantum mechanics and statistical mechanics. Most recently, he's been developing an account of laws, counterfactuals, and objective probabilities. He's been collaborating a lot with David Albert on the interpretation of quantum mechanics and the role of chance in statistical mechanics. Barry?
Thanks, Priya. So thanks for inviting me here. Priya says that we're really under time constraints, so there were so many interesting things brought up by the two talks. Here's a little list of things that struck me as I was listening to the talks. Look at it quickly because it's going to go away. So I'm just going to focus on some of the issues Tim brought up, and even so, I won't really be able to say very much. Let's see, where are we here? Okay, is it sign? Okay. Okay, so I just want to talk about the fine-tuning argument a little bit. And here is a way, not exactly the way Tim presented it originally, but the way somebody might present it. You know, given the fundamental theory of the world, there are infinitely many ways the universe could be. You might think of these, possible universes, so to speak. Not necessarily actual, but just ways the universe could be, with different initial conditions of different constants. Any one of these is infinitesimally unlikely. I suppose there are infinitely many of them. The probability, in some sense of probability or credibility, of a universe being one like ours that contains stars, supports life, and so on, will then be very, very tiny. Given this thought, it is shockingly surprising, we might say flabbergasted, which I learned was a term first used, this is after David used it today, in 1772, to mean being so aghast that your flabber is moving up and down. Your flap is moving up and down. That it's literally, this is what the online dictionary said. But if there were really sufficiently many actual, not just possible, but actual universes, then the credibility that at least one supports life is very high. There is life, so it's likely that there are many actual universes. That's supposed to be the thought, I think. And this argument could be given, as Tim said a few times, way before anything came up about quantum mechanics or general relativity or inflationary cosmology or string theory, anything like that. Those theories may, or some of them, may imply, in ways that were talked about, a multiverse as well, and we might have evidence for it, but that's not evidence via the fine-tuning argument. This is of the fine-tuning argument, and it could have been given by, somebody who was a friend of Laplace's. So here's a fine-tuning-like argument that seems to me to be obviously good. So imagine you know that you'll be put to sleep, and then a pair of dice will be thrown either once or be thrown 1,000 times or many times. If the dice land snake eyes at least once, you'll live and be awakened. Otherwise, you will die in your sleep. I guess this could be like Tim's experiment. We won't do that. But anyway, you wake up alive, and you conclude that it's likely that the dice have been thrown 1,000 times. That seems a good argument to me. And I think that's something like the thought behind the fine-tuning argument. Of course, you got to start with some prior probabilities that are in these two hypotheses, bigger than zero, prior credibilities in them. And really what's happening is that the evidence you get is evidence for one of them and against another one, and so your probability you end up with, the posterior probability, will be dependent on both your prior and on the evidence. Okay, and this kind of reasoning, I don't mean to introduce anything really fancy here, but it's nice, and it helps me to put this in sort of Bayesian form, in part to remind myself that confirmation, or evidence for, at least in my way of thinking about it, really always involves comparisons among hypotheses. I don't think this is, something that's absolutely universally accepted by everybody who thinks about evidence, but I do think it's relevant here. We're always comparing hypotheses, a multiverse hypothesis versus a creator hypothesis or something like that, or a universe is just that way hypothesis. Okay, so in this argument, we're supposing a kind of chancy process chancy processes involved. If we compare the two arguments, there's some things you notice right off. One is that in the fine-tuning argument I gave us, there wasn't any real chancy processes. In fact, question arises, what do the probabilities there mean in the fine-tuning argument? Where do they come from? What underlies them? That's the questions over here. So Tim recreates it using the notion of typicality. And this is a really interesting notion. And a question that I'd have, and maybe Tim will say some more about it, though, we've been in discussions a bit about this before, is exactly how typicality should get connected to credibility. Because it's credibility or credence that's really relevant in the in confirmation. Notice this, Tim kept talking about typicality in terms of most of situations. The typical ones are the ones that most situations have. But we're sort of in a regime where, although not everyone here would like this, where it look like there are infinitely many possibilities of both kinds, infinitely many states in which there's the universe evolves to have life, and infinitely many in which it doesn't. It's rather typicality is determined relative to what Tim calls a natural measure. So if we make certain assumptions about the laws of our universe, there may be, in fact, something that strikes us, physicists, as a natural measure, as Tim says, over the state space that goes along with the laws. This is certainly the case in classical mechanics and in various other theories. But why should we think that this measure, which has certain good mathematical features, maybe certain features that fit in with the dynamical laws of the theory in a certain way, why should we think that it has anything to do with credibility? So that's a question for Tim. Good. The multiverse hypothesis, sometimes taken as an alternative to a kind of a creator hypothesis. It's also not clear to me how you're actually supposed to apply the argument in this case. I mean, what's the probability that there are stars, that there's life given G, that there's a deity, that there's a God? I don't know. It's just very obscure to think about this likelihood. And in fact, given total evidence, maybe theologians would say something about this if they want to engage this kind of an argument. Look, our universe has life in it for sure, but it also has a lot of loneliness in it, a lot of empty space, a lot of suffering in it. Well, this is all very familiar. So I don't know how one would evaluate the probability of the total evidence on a theological hypothesis. In any case, it doesn't seem to be anything like a scientific hypothesis. Okay, Tim brings up a very interesting kind of a line of thought about the fine-tuning argument, and that is that argument, and in fact, really this is a situation that happens in a way sort of independent of the fine-tuning argument. As he pointed out, it's something that happens within certain views about statistical mechanics, and it could happen also within certain of the other multiverse theories, that it might be that the theories produce too many universes. Okay, so Tim's line of thought that led to, in the end, to a sort of a question about an argument, and then a sort of puzzle about what was going on in the argument, is a line of thought that you could be led into by the fine-tuning argument, but you could also be led into it in other ways as well. Okay, so as Tim points out, some of the mechanisms for producing universes produce too many. Boltzmann's statistical mechanics is like this. I guess quantum fluctuations would be like this too. So Boltzmann supposed not a chance universe creating process, but rather, as Tim pointed out, a kind of probability distribution over physically possible microstates in order to account for the second law. Given this distribution, given a distribution, the probability distribution over the present macro state, it implies that the entropy of the universe and typical subsystems implies, in the sense that Tim was saying, Detlef says is, we're told this by our betters, that the entropy of the universe and particularly of subsystems will likely increase to the future. And because of the temporal symmetry of the dynamical laws, Boltzmann's assumption also implies that entropy likely increases to the past. Of course, we don't believe that. We think that an ice cube, an isolated pail of water, will melt, but that it was larger, not smaller in the past. Boltzmann, though, unlike Tim, thought there was no metaphysically fundamental arrow of time, but rather that the universe looked something like this. So Tim stole this picture from someplace. I stole it from Tim. Tim explained the picture. Okay. So Boltzmann thought that there was no metaphysically fundamental direction to time, and in fact that the universe was totally symmetrical, physically symmetrical, and that it spent most of its time, and I guess this was a slightly misleading thing about this picture, it spent most of its time in just downright equilibrium, with fluctuations out of equilibrium from time to time. But there's no flow of time in this. There's no direction of time. There isn't even this end is different from that end in this. There are no ends. Infinite. It's an infinite universe. And Boltzmann, I think, thought then that this could account for the direction of time by locating us in this picture someplace, locating us, as Tim also pointed out. I don't have the ability to make little dots over there, so I'm going to do, but someplace on an upward swing of one of these entropy dips. Oh, there. Good. Okay. Now, as I'm saying, in this account, there's no arrow of time, not even in some sense. Well, there's no arrow of time, but rather the distinction between past and future arises from where we are in the multiverse. Okay, just as I was saying. All right, now here's the problem that Tim brought up. In Boltzmann's multiverse, there are infinitely many universes which contain a room just like this one and a brain just like yours, but in which outside there's a soup of particles or fields or whatever that's at equilibrium. And in fact, the probability of that on this account, just from the probability distribution, is far greater than there being outside of this room, Yale and New Haven, and a past more or less like we think the past was. Okay, so this is the problem of Boltzmann brains. Well, there is a suggestion about how to avoid this problem, and that suggestion is the other alternative that Boltzmann mentioned. That alternative doesn't presuppose an arrow of time, maybe, but what it does presuppose is a boundary condition to the universe, in which is with very, very low entropy. Maybe it's not by boundary condition necessarily in some sense there may be other things that go on in a temporal direction away from it and away from us. But there's this very low entropy condition. Let's just think of it at one end of the universe. And an interesting program, the program that David was explicating a bit earlier, is to argue that this very low entropy condition, the so-called past hypothesis, can actually earn its name as past hypothesis by showing that what we think of as the other arrows of time align with the entropic arrow, align with it. But this doesn't quite solve the problem. A point that's been driven home in my own mind by Sean Carroll's discussion of this is that the universe will continue to go on to exist. And so even if you have a universe with a boundary condition that's very low entropy, and looks like the picture we looked at before, then it will go on forever, and you'll still get lots and lots of Boltzmann brain, fluctuations into Boltzmann brains, rooms like this one, but outside there's equilibrium, and so on. Now here's the argument that Tim was giving, or his experiment and Feynman's argument. So it is just a quote from Tim's paper. The argument is that, look, well, it looks like we can provide evidence against this multiverse hypothesis by just doing the little experiment of opening the door and seeing that there's things outside the door, or turning the telescope and looking at other parts of the sky, and so on. So Tim takes this at first as demonstrating that, or looking like, that it's this simple argument shows that the Boltzmann multiverse hypothesis is false, or there's strong evidence against it. Or at any rate, that's how Feynman, I guess, was taking it. So I don't understand the logic of this really either, but I have two things quickly to say about it. One is that one might say that the argument doesn't show that there's no Boltzmannian universe, multiverse, but rather what it shows is that we're now located in a time somewhere between very low entropy state and the equilibrium. If we think of the picture in which the universe has a boundary condition of a very low entropy state, the past hypothesis, and then it goes trillions of years in the future into equilibrium, and then fluctuates in the Boltzmannian picture after that, we could take this argument as providing evidence. We're doing an experiment, and the experiment shows that it was very unlikely that we were at an entropy minimum when we just took into account the state of our brains, or the macro state of this room. And so we got evidence against that, and so evidence that we weren't, and so evidence that we were during the time prior to reaching equilibrium for the first time. So that's a stab at how this argument might be understood, though it will involve making sense of self-locating probabilities. And I'm really not sure exactly how to develop this into a general account. But there is another point that's an interesting one about this line of thought, to this argument, and that's this. One of the Boltzmann brain hypothesis is in a certain way cognitively unstable, as in fact was the Boltzmann probability distribution in the first place when we were just thinking about it before we introduced the past hypothesis. Because if in fact we're at an entropy minimum, then all of the evidence that we think we have, physicists think we have, we think of as written, that we think are written in the books that are in this room and so on, more likely appeared as the result of fluctuations than as representing being veridical evidence. And this leads to a kind of cognitive instability. So the Boltzmann brain hypothesis has this problem of being cognitively unstable. If in fact you were to take it seriously for a minute, you would realize that it was giving you reason to take it unseriously, to reject it, because it would mean that the evidence that you thought you had for the, let's say, the dynamical laws or the second law, the evidence that you had for that is likely not to be veridical evidence. So one condition on a good theory is that it's not cognitively unstable. And so one thing we might do is from the very beginning just rule such theories out in confirmation, assign them credibility 0, as we do for lots and lots of other kinds of alternatives, like that the universe was created 5 minutes ago or 15 minutes ago, and so on. That's it. That's what I have to say. I think thanks.
Now, I'd like to invite our second commentator, Professor Janet Soskice, who's a professor of philosophical theology and a fellow of Jesus College at Cambridge. And her research interests have been in the philosophy of religion, ethics, and these are courses she has taught. And she has had a very interesting recent book called The Sisters of Sinai, How Two Lady Adventurers Discovered the Lost Gospels. Janet.
Thank you.
I love that book.
All right, good. Also one on creation of the God of Abraham, which was creation ex nihilo in 3 traditions, which I think may have been the ticket that brought me here. Anyway, I'm delighted to be here, and And I realize time is pressing. And in a sense, you'll be relieved to know, perhaps, that is the universe unique is a question on which I think theology, of Christian theology, is largely must be indifferent. I don't see any reason why Christian theology should dictate a particular view on this. Now, if the question had been, is creation unique? The emphatic answer would have been yes. But there's a difference between talking about the universe and talking about creation. Now, the Christian and Jewish and Islamic belief is that there's a creator God and that there's one creation, but conceivably, if we go back to the cartoon, I think it was, I'm not sure whose cartoon was it, Bernard's cartoon of God poking a paper bag full of brains, and which one to choose. Well, the point, that wouldn't have been the picture. God would have created the whole bag. And so if there's multiverses, fine, you could still have a creator God. In fact, the theology of creation in Judaism, Christianity, and Islam, which is what I know most about, is not, as you know, and as others have said, principally or even at all, really, a branch of cosmology. As Dennis Turner said last night, it's been extremely misleading, the discussion over the past 20 years, particularly in the States, about these 6 days of creationist stuff. And that's not the classical Christian teaching about, center of the Christian teaching about creation. And as Joel mentioned, indeed, Augustine, but many of the fathers, Philo of Alexandria, a first century Jew, all understood the creation stories of Genesis to be figurative, for the very simple reason that the sun and moon are only created on the 4th day, and you wouldn't have had day and night before that time. Indeed, in the early stages, there was incredibly sophisticated talking about space and time, temporality and eternity, which is entirely blasted out of the water by all this tedious stuff about the 6 days. I'm sorry to anyone whose faith rests on all that. But there you go. Mine certainly doesn't, although I am a foursquare Christian, even Catholic, I'll confess, theologian. So I want to say that if we look to antique theology, then we do see the same confluence of philosophy, cosmology, and theology, which we're experiencing these couple of days. Sophisticated pagan thought in antiquity was monotheistic. Plato and Aristotle were both monotheists of a sort. And the Jews were admired by the philosophers for this monotheism. Judaism was praised as a monotheistic religion. And there was indeed a great deal of contact between Jews and Greek philosophy from about the 3rd century BC, because after Alexander the Great had pushed all the way to India, Greek was the lingua franca of the educated world. Hebrew was a dead language. Most educated Jews spoke Greek. Even in Palestine, we now believe that this was the case. And for many, if not most, Greek was the first language, so that they would be educated in Greek paideia and so on. So now if we look, though, at Aristotle's monotheism, it is certainly not very like that which seems to be sketched in the Hebrew Bible. God in Aristotle's scheme was indeed not really part of his theology. It's hard to say whether Aristotle had a theology, but God was an aspect of his scientific theory. And indeed, Bernard, you'll have to update your map, because God was a big part of Aristotle's natural science. But God was not a creator God in the Jewish or later Christian and Muslim sense. You could not have the universe without God in Aristotle's scheme, but equally, you could not have God without the universe. They implied one another. Maybe we could say in a clipped way that God's like the DNA and certainly the telos of Aristotle's universe. Aristotle's God famously had no knowledge of particulars, and Aristotle's God and Aristotle's universe were everlasting. They had no beginning and they would have no ending, and famously summarized in what we now know was the motto of George Ellis's primary school, ex nihilo nihil fit, from nothing, nothing comes. Now, this was not acceptable to Jews and, as they later emerged on the scene, Christians and Muslims. The books of the Bible seem to say that God had created everything and did so freely, from no compulsion, and furthermore did so from nothing. Now, theology, this creation theology, did not principally come from the book of Genesis. It came rather more from Isaiah, particularly also from the book of Psalms, where you read such things as, our help is in the name of the Lord who made heaven and earth, And from another one that was often cited by the rabbis, for God spoke and it came to be, he commanded and it came into being. These kind of sentiments are absolutely rife in the Psalms, and the book of Isaiah, also famously the book of Job, is a great deal about the theology of creation too. So from this emerges a certain picture of God, who, unlike Plato's demiurge, did not mold pre-existing matter. Nothing pre-existed this God. And there's a tension in the Greek-speaking milieu of Hellenistic Judaism over this. You can almost hear it happening, sort of Greek-speaking Jew, God made everything, sort of Platonic philosopher or, Aristotelian, everything, really everything. Did God make matter? Did God make space? Did God make time? Now, by the 1st century, there was an emergent consensus that God made really everything in this sense and did so freely, and that is the teaching that we call creation ex nihilo. And it should be said that creation ex nihilo is not the only or obvious reading of the book of Genesis. It is an emergent view, and it's driven not by trying to figure out how the world works, as we're mostly discussing here, but trying to figure out who God is and God's relationship to the world and to human beings. But you get something happening that forces a rupture in Western metaphysics at this time in the 1st and 2nd century, and it comes really, I think, from Hellenistic Judaism. And it is that you get this idea of radical divine transcendence. Our first witness to this is Philo, as I've already said, a Jew of the 1st century of Alexandria. And Philo is convinced that God made everything, including space and time. God is creator of all that is. God is in no way a creature. God, because of this, Philo has a radical crisis over how we can say anything of God, because he realizes that we, in the grammar, the Greek grammar he's inherited, to speak of God, to name God, would be somehow to delineate God's essence. He believes that this is not possible because God isn't a creature. All our language is appropriate to, medium-sized physical objects like refrigerators or flasks, perhaps, in Philo's time. And so we can't really speak about God. So this precipitates a great crisis, but also many interesting things, including the idea that comes in this period, which we often call Middle Platonism, that God is being itself and the source of all being. Now, understood in conjunction with Jewish and Christian thought, this does not mean that God is the biggest being on the block. It doesn't mean his great big creature from whom everything oozes out. It means that God is being itself, but not a being amongst other beings. Rather, their relation to him as creatures, and he is the creator. So this radical transcendence was quite important and basically seeped into Greek metaphysics, Neoplatonic metaphysics, Proclus, Plotinus, and was a dominant kind of metaphysics right through the late medieval, the Renaissance period, I suppose. And it's based, I think, fundamentally on this teaching of creation ex nihilo, which is not, it's a metaphysical teaching, it's not a scientific teaching. Yet at the same time, it holds quite a lot of promise. And it had some very interesting repercussions. Philo suggested that God made all that is, including space and time, and this is a consensus of the early Christian fathers who followed. And this becomes a forcing house, for instance, in the 2nd century on the whole question of dualism, because there were a lot of dualist groups around, and that suggested, for instance, that human beings were spiritual beings who were trapped inside nasty material bodies. The Manichaeans that Augustine hung out with for some time seemed to be like this. And so the idea would be to purge yourself of your bodily elements by fasting and spiritual exercises, and then the soul would zim up to God. But creation ex nihilo goes right against that, because it says basically the soul is as much a creature as the body. All these things are creatures. Angels are creatures. They're not material creatures. And I think this bears to the idea of, could there be multiple universes? They wouldn't use this lingo. But in some sense, already you can see you've got the idea that they are God. There's a whole realm, which is often in the creed called things visible and things invisible, that are not material at all, that these people believed in, that nonetheless they believed were created by God, whether we do or not. So this is to just show this radical transcendence behind the doctrine of creation. God creates space and time, and it's already been invoked, the ridiculousness, as Augustine insisted, of those who kept asking what God was doing before he made the world, before he made the universe. This collapse of language, the stretching of our thought, but also something interesting about time, which may fit in with Julian's thought, I don't know. But of course, if God is the creator of time and not a creature of time, then to some extent for God, creation is now. Creation is not a long time ago. From our point of view, if there's an initial singularity, it's a long time ago. But from the point of view of many theologians, creation is absolutely now. And another corollary is that everything that is a gift. Everything that is at any moment, not just long, long time, ever many billion years ago, everything that is only has its being and is held in being because of God. Well, those are just a summary of some of the things about the doctrine of creation, which I think there are resonances with a lot of aspects of what we've been talking about today, and most particularly with what Barry said. This is not to say we understand the logic of it. Thank you.
Actually, I'd like to invite all the speakers and the respondents to come up here to open up to the floor for questions. Okay, we're ready to roll. Questions? David?
So this is a question for Tim, and I guess following up on something that Barry said. I mean, I find myself really puzzled by this too, but I guess I was puzzled at an earlier stage than you got puzzled. That is, in the initial Feynman spiel about disconfirming Boltzmann hypothesis. This is just sort of picking up on what Barry was saying. I don't understand. So what we're supposed to be entertaining for the purposes of confirmation or disconfirmation is that we're in this condition where we're supposed to be entertaining a certain claim about the dynamical equations of motion, okay, among other things, which entails, among other things, that the reasons we are telling ourselves we have for entertaining those are bogus, right? So there's some sense in which I don't even understand the setup, okay? That is, I don't understand how we would ever get into that. I can imagine very artificial circumstances. God tells us, these are the equations of motion, okay? We don't believe them for the normal reasons. God just comes down and says, these are the equations of motion. Don't worry about how you know they're because I told you. Okay, they're the equations of motion. And you're supposed to contrast, then you're supposed to go out and do experiments in order to compare the hypothesis that you've been on an upgrade for a long time, or that you're now at an entropy minimum. I guess in a case like that, you could tell Feynman's story and maybe it would make sense. But is that what I'm supposed to imagine? That seems like a very artificial scenario. That is, it isn't like we did the experiment here in the way you were describing, because those aren't the reasons that we took ourselves to have for believing in the dynamical equations of motion. Am I making any sense?
Look, I understand. Sorry. There is this curious thing, and Barry's perfectly right, this cognitive instability issue. I mean, yesterday we named Kant got thrown around a bit, and here Kant might be very happy. Of course, but that's puzzling too. It's like saying, look, here's a theory, it's kind of internally consistent, but somehow if the world were like that, you'd be in some terrible, weird epistemic situation, hopeless epistemic situation. Therefore, don't consider such possibilities. Or, I mean, it's, but this is, of course, an odd thing. You might say, yeah, too bad for us. All Feynman was doing, as far as I can tell, as you say, was just taking for granted the dynamics.
Right.
And comparing the very thing Boltzmann compares.
But
that
I
is,
guess
that
here's
is here are two implementations of it, one with a finite universe, one with an infinite universe. And Feynman thinks that one says, one hypothesis is we're in an infinite universe and we fluctuated down, right? The entropy, the low entropy wasn't initial, it was a result of a fluctuation. This actually I think the best way to read this is that there is a direction of time, because the idea is somehow these are improbable fluctuations. You have to think you're tracking time in a certain direction. And then he argues, the argument is, given those two hypotheses, here's a little experiment,
Right.
which he thinks will actually decide between them.
But all I'm asking is, I mean, God forbid we should make Kant happy here. But is ought it to play some role in these considerations to say, but wait a minute, we never could have gotten to that point by any rational program of confirmation
Right.
that we
So,
could imagine. We never could have gotten in this position.
All you said was you got confused earlier on, and I agree with you. Okay, that this is yet a meta level of confusion in the situation,
Right.
and I absolutely agree with you. And in fact, Joel was saying, look, what's the problem? What we know is that we started from this low entropy state, and considering all these other possibilities is kind of irrelevant. The puzzle for me was just I mean, there are two parts of it. One is that there is a pull, right? There is this kind of pull to what Feynman's doing, so that I can't get rid of it. But it's even more than that, and this is a little bit to respond to Barry. It's not that I think typicality implies credibility, right? That's more or less what you were saying. But the claim was, we do think it's somehow, if it can give you a kind of explanatory closure, right? Now, that's not to say that you ought to believe before you look whether what you'll see is typical, right? I mean, if you close your eyes and you say, how much should I believe when I open my eyes? I'll see something that you call typical, that you, by your calculation, is typical. I don't know, right? The claim is rather, if you see what's typical, somehow you've gotten an explanatory closure there. And if you see as atypical, you're in a different situation, and it's one that you haven't refuted the theory, but you're looking for some other explanatory resources. I think I simply agree with you that there are these further self-undermining issues about certain pictures. Now, what's clear is that none of the multiverse people who talk about, none of the physicists who talk about multiverses consider these Boltzmann types with all the little fluctuation-y guys in it, right? They seem to be considering, like in the eternal inflation scenario, each one starts in a big bang. You don't have any ones that, as it were, fluctuated down into the middle, which are the ones that gave us problems here. This is to their credit. That is to say, it looks like they're avoiding, or at least not considering, the kind of problematic multiplicity that I was worried about, although I don't know whether they're justified in that. I mean, certainly the more loose they become about, if you go as far as level 4, you'd think the problematic ones are certainly mathematically possible, right? So at least the methodological situation. Now, maybe they're justified. Maybe it's right to say if you sort of work through these models, the models just don't produce the problematic guys. So, I mean, I don't know if that helps a lot. But I do agree with you. There's this, this cognitive instability thing is also something that...
Tim, do you regard, Boltzmann brains as all being part of tape mark level 1? In other words, this is all going
for
on
Boltzmann, it was, yeah.
Yeah.
I mean, that's all Boltzmann was. Boltzmann was just considering a world that was infinite in time and space, with one set of classical mechanical laws, but closed, so so that it would be ergodic and go through all the possible states, right? And this is just a consequence of that, right? That was just
even if the production of the worlds is through Big Bang states.
That's right.
Statistical mechanics will imply that they'll go on forever in a Boltzmann way, and so you get Boltzmann brains anyway.
That's right. That's right.
Joel?
Well, I just wanted to try to make the point that that argument concerning Boltzmann brains and Feynman's refutation and so forth doesn't make any sense in the context of standard modern cosmology. It's a pre-cosmological argument. In Big Bang cosmology, the whole universe should look exactly the same because it all came from some much smaller region that in inflationary cosmology was once homogeneous in causal contact and so forth. And this problem that you're effectively referring to is related to the standard problem, one of the 3 standard problems solved by inflation called the horizon problem. Why is it that the universe over there and over there have the same temperature to within a few parts per million as measured, since there hasn't been time for the light over there to get to the light over there, it's just had time to get to us. So they couldn't have known unless there was this prior setup. So once you solve that problem and the other related problems that inflation solves, then it seems to me you've solved the fluctuation problem on the small scale of the part of the universe that we can see. And then if it arises at all, it arises on the super universe, these multiple different causally disconnected regions, which could be extremely different from each other.
Right. Can I just make a comment about this? Because to illustrate how puzzling this stuff is. I know that my colleague, I guess ex-colleague, Shelley Goldstein, and I guess he reports Roger Penrose, hold the view that the problem you just mentioned about the constancy of the temperature of the background radiation, that you don't need inflation to solve it for exactly the reasons I just gave. That is, what they say is, look, suppose there's a certain amount of entropy, a certain amount of energy available, and you're going to distribute it. A typical distribution, right? And these will be essentially equilibrium, right? A typical distribution, if by normal measures over the phase space. I'm just reporting, okay? So he says there was, but
equilibrium.
No, the claim is there was nothing that exactly because what you would expect is constant temperature by typicality arguments, you don't need to invoke inflation to explain it. Now, maybe they're right, maybe they're wrong. It's just to illustrate that these are very subtle issues here, right?
Anyway, inflation not only solves the other problems.
Right, there may be other things that inflation.
It naturally explains the nature of the fluctuations, the very small fluctuations.
Right. That's a different issue.
That give rise to structure.
Absolutely.
And to my knowledge, there's
no
absolutely.
That's a much more impressive looking. Right. I think if I understand it, I only know it at this very thin, surfacey level, that the specific distribution of the fluctuations looks like very strong evidence for inflation. The interesting thing was that people often took just the constancy of the background radiation itself to be kind of strong evidence that you needed something like that. And at least there are people who argue that, no, I can just do that by typicality without any of that stuff. So it's just, again, illustrating that the exact structure of these arguments is a bit fluid or a bit hard to pin down.
Michael?
This is a question for Tim. I didn't understand a move you made at the very end of your paper, so my confusion came at the end. This is at a very general level. So it seemed to me your paper had the flavor of Moore's paradox. Like, it's raining, but I don't believe it. So you had this very powerful argument, very compelling, against the multiverse view. And then at the end you said, well, I don't see how this quite works. So here's a counterexample to my argument. But I'm going to believe my argument anyway. So So what was going on at the end of the paper? Why?
I'm puzzled.
Why is it just a puzzle? Why didn't it just lead you to reject the argument?
Okay, so here's why I'm puzzled. Boltzmann did something right. Okay, I mean, I just take that as a given. When you try and explicate scientific methodology, you have to have your paradigm cases of good scientific work, right? I mean, either you have some a priori principle which can lead you to reject all of science from beginning to end, or you say, look, here's some examples of a scientist really having accomplished something, right? And I take it, and maybe I'm wrong about this, but for me, when I read Boltzmann, and I think, did he really explain, the ideal gas laws? And yeah, he did it, right? There's in that work, there's really something that has good explanatory power, and when you sort of work through the details, that's why. I mean, you might just say at the end, if I'm so puzzled, why don't I just throw the whole thing overboard, right? Give up on all these typicality arguments. And I think because there are things that are in the neighborhood that really just seem right, and sorting out the appropriate from the inappropriate applications is very simple.
To you after this argument that you yourself gave. So that's yeah, sorry, similar, I guess. But I'm not sure why you're.
Because steam engines work.
Yeah.
Tim, I mean, the problem really isn't with typicality arguments, because even if you didn't think that it was the measure is a typical measure and that's what determines that it's, the second law, you get the second law from that, but just thought it was probability and there was some counter probability, you'd still get the same problem, right?
Yeah.
Yeah, so it's not typicality that's
No, yeah, but it's,
okay.
yeah.
Right, so I was suggesting that the argument may show not that the Boltzmannian account is wrong, but show rather that we're likely to be located in the first, in an upswing. That could be a way out if you could make that argument really explicit.
Yep. Ken.
My question is for Bernard. In the multiverse theory, how does this work around the infinite regression problem?
Sorry, in the which theory?
The multiverse?
Yes.
With our multiverse, and you said that there was a finite number of them, there wasn't an infinite number of them. But how do you go back when you come to the first universe and not have a infinite regression, that universes are just kind of one after another after another?
Well, I mean, that depends exactly which theory you're talking about. I mean, in the context of eternal inflation, there is the issue of whether there are indeed an infinite number, to the past and the future, which is the most natural interpretation. What I said was that the picture itself does not require that there be an infinite number of universes, which relates to the discussion we had yesterday about whether infinities are physical or just mathematical. If you take the view that the likelihood of having the life-conducive conditions is very small, I mean, 1 in a million, say, I mean, how one calculates that probability is rather vague, but if it was, say, 1 in a million that the constants would have the values required, then you would merely infer that you need to have 1 million universes in order to have a reasonable chance that we should be here. Unless the probability is really going to zero, you wouldn't need an infinite number of them. But no, if you ask the question, how many multiverses do you actually expect to exist? I mean, of course, that would all depend on the scenario, and it would all depend on other factors. For example, in this, I showed a little slide which had this little universe-producing steam engine, puff, puff, universes came out. I mean, presumably the number of universes depends how long you keep it on for. I mean, so, and of course that's not well defined from a physical point of view. I sort of share George's aversion to infinities, and therefore the only statement I make is that you don't need an infinite number of universes in order for the multiverse hypothesis to fly, from the perspective of the fine-tuning arguments. I mean, remember, the fine-tuning argument is not the only argument, and indeed, for many people, it's the least convincing argument. I tend to quite like it, because in the days when we were talking about fine-tuning, we sort of, myself and Martin Rees, we wrote a paper about this 30-odd years ago, and even at that point we said having something equivalent to a multiverse would be the best explanation. But I mean, that's not to say there wouldn't be an infinite number. It's because if you've got a machine which can produce them, why shouldn't it produce an infinite number? But but it's not really a well-posed question within the physical theories that produce the multiverse.
I guess in the sense of from a theological and also from a philosophical perspective, that in speaking as a Christian, you have nature tells us something about the nature of our creation, tells us something about the Creator. And for Aristotle, creation, the first mover, the unmoved mover, is reflected in this nature, in this world. And so from a perspective of a multiverse theory, I don't have a problem with a multiverse theory. It's just a question of, is that at how many, and then where does it begin, which was the first, and then where does the sequence come from, or is there a multiple? I have no problem with God blowing bubbles, but is it one bubble with 3 pieces at one time? I mean,
it's interesting because that does relate to the whole question which none of us really talked about. I mean, except to some extent, the God versus multiverse picture. And my own view is that, in trying to decide between, I mentioned the possibility of a fine-tuner as opposed to having a multiverse. I explained the fact that, maybe theologians prefer a fine-tuner, most physicists prefer a multiverse. Actually, most physicists don't want either. Most physicists regard a multiverse just as mystical as a god. But for those subsets who do, which includes prominent people like Martin Rees and Steven Weinberg and Soskice, etc., it's you can't. From my perspective, it's actually very hard to decide between these two hypotheses, I take the view that if there was a multiverse, it would not in any sense mean that you would have to reject God, because obviously if God can create one universe, he can obviously create as many as he would want, and therefore why shouldn't he use this universe-making steam engine, to produce the universes? I think what is true, though, is that if there really is only one universe, and I mean only one universe in the sense of level 2, if there's only one universe, I do think these fine-tunings give you a problem. If you're an atheist, I think it was Neil Manson who said that the multiverse is the last resort for the desperate atheist, because if there is one universe, I think there is actually a problem, in the sense that you might be forced to something like a creator. If there's a multiverse, it's impartial. It could go either way.
Okay, Dennis?
Yeah. So far as I can see, if you're a Christian theist, I think Janet probably would agree with this, you don't need to believe that the universe is finitely old. You can happily believe in multiverses, any version. At any rate, you have no reason to deny any versions of them. And finally, just in relation to that last remark of yours, Barry, you don't need to accept the fine-tuning argument. Reading, I'm not quite sure what he means by chance and whether it fits with any accounts of chance with which physicists would work. But I read Thomas Aquinas recently asking the question, can God bring about things by means of chance? And his answer is, yes, of course. There's no problem about that. So this, I think, drives the coach and horses through a lot of versions of the so-called design argument. And I just wonder whether the fine-tuning argument isn't just an updated version of the design argument, which it seems to me doesn't really get you anywhere. No.
Is that for Janet?
Janet may not agree with what I'm saying about the implications of what Christian theism seems to have for these things. But it seems to be largely neutral in relation to pretty well anything that's going on within the disputes within physics.
And there is another issue that you get to with going into the fine-tuning thing, which is the question of being a little bit too hubristic, as we've invoked the term, about the mind of God. There are plenty of biblical passages, Job famously, where were you when I made the wind and the stars, that sort of rather caution against saying why that God made the world in this particular way so that we would end up with, our little four-wheel drives and guinea pig hutches or whatever it is we have. And I think that there's just an element of that also gets you into some difficult theological territory, because if God is creating space and time itself, then any talk about intention and planning is very difficult. You have to qualify that, as Aquinas knew all well, because all our language of intention and planning suggests temporality, and that can't apply in the same way.
Laurie, then.
Okay, a question for Bernard, actually. So I'm just trying to understand the way that you're thinking about this. And so say I'm taking a train into an area I've never been to, and I take the train and I get off at a stop that looks interesting. When I get off the stop, I look around, I find myself in a junkyard, and I look at it very carefully, and I think, oh my God, this junkyard is so incredibly complex and interesting, and look at how that bit of metal is twisted around that other bit of metal, and the aesthetic splendor involved in whatever. Okay, and then I look and I look at all the different details of the junkyard. It's incredibly complicated. I think, how incredibly amazing that these pieces of metal were twisted in just this way, with just this distribution of rust. What's the best explanation for it? And then I reflect for a little bit longer, and I think, oh, that's it. There are almost infinitely many different junkyards in this new location, and and I've just happened to get off at one. But obviously, I need to explain this complexity, and that's the best explanation.
I mean, yeah, I mean, this sort of also relates a bit to what I think Tim said about there's nothing specific to human beings. So it would apply equally well to TV sets and things like that. Now, I mean, so you're saying, what is there? I think essentially you're asking, if you believe in some sort of selection effect, some sort of fine-tuning, what exactly is it you're fine-tuning for? In other words, you're saying, obviously, any configuration is unique. It's like saying, I choose a number. You choose a number, and you say any number is unusual. But there are some numbers which are special. So you choose the numbers which, say it's 3.14, whatever it is, the digits of pi. Okay, you know that is different. It's not just any old configuration. So I'm using the analogy of a number as opposed to just twisted bits of metal. And so I would say that there is actually something. It's not just. I mean, the first point we're making is that to have any configurations of metal at all, you need certain conditions. You know, but even given that, the fact is, I would say there is something rather special about the structure, the sort of complexity that arises in this universe, that it's not just random, it's a sort of complexity which gives rise to self. Well, actually, I personally think the peak of that pyramid of complexity, logically speaking, the most complex structures on Earth, at least, are brains. I mean, the brains in normal brains, not Boltzmann's brains.
And they're complex too.
And they're complex too, yeah, but brains with bodies. And it seems to me that there is something rather special about that. It's not just a random wrapped up piece of metal. It is something which has particular abilities to self-cogitate, etc.
So, I mean, what I wanted to know is what you thought went wrong in the inference that I made, and because I'm not seeing why the same thing isn't going wrong in the inference that you want to make. And I'm...
Well, I mean, put it this way. I mean, to have any bits of metal at all requires certain fine-tuning. So I think you're sort of saying that what's special about our brains, for example, as opposed to just the random junk, random heap of matter. And there are different ways of answering that, you see, because there are other explanations for these fine-tunings which actually says that you actually need to have a build-up of life, if you like, or something which some form of consciousness which actually creates the initial conditions. And we've talked very much as though it's a matter of God versus multiverse. But Paul Davies has a very different view, which simply says that you have to build into the universe that once life arises, once consciousness arises, it sort of reflects back on the origin and changes the laws of nature in such a way that it happens. So that's a third way, if you like, of trying to explain these processes. Now, if he were to take that argument, he would say then the random, pile of twisted metal would not work. So, I mean, I'm saying that's a third approach to the problem.
Okay, George, then Joel.
I have four brief comments. The first is about the mechanisms, and obviously if we knew there was a mechanism which worked and that was a tested mechanism, then this would be very convincing. There's at least three very hypothetical steps in the current proposal. The first is chaotic inflation is not the only form of inflation. Inflation is not a well-defined theory. It's a vast family of theories, some of which are chaotic and some of which are not. The second part of the mechanisms is the string theory landscape is believed by a small part of the string theory community. There are many members in the string theory community who do not believe in the string theory landscape. But the third and most important point is if you have both of those in place, there isn't a mechanism, which means you have to have a different part of the string theory landscape in each of the bubbles which occur. So there's three problems with the mechanism. The second point is the famous Weinberg argument about lambda, and you talked about this. It's a probability argument for why lambda would have the value it would have. The probability argument only applies if there is a multiverse. If there's no multiverse, the argument simply doesn't apply because there's nothing to apply a probability argument to. So it's a consistency test on multiverses, but it's not a proof in any sense. The third point is that I do think it's important to note that, at least from my viewpoint, multiverse enthusiasts are actually advocating weakening the concept of what science is. They're saying we don't worry so much about proof. Proof doesn't matter anymore. We've got really good theories and we must believe our theories and don't worry that we can't prove it. Now, this to me is stepping back 1,000 years in terms of science, or at least it is threatening to do so. And I think one must realize there are many, many other explanatory theories in the wings which satisfy all the other criteria. They're generic and they've got power and so on. But the thing they don't satisfy is the testability. And astrology is one, intelligent design is another. And the thing about it is whatever arguments are used to support the multiverse, you've got to say to yourself, well, what happens if I apply those to intelligent design or to astrology? What are the conclusions if you've weakened your concept of science, if you apply it in those kinds of situations as well? And but by the way, I think it's very funny. When Martin Rees was awarded the Templeton Prize, Dawkins and company jumped up and down and said, science is about proof and we're about proof and this is faith and, science is superior. And he then, in his book, says that we must believe in the multiverse because this is the way to do it. And so he sticks to proof when it suits him and he abandons proof when it doesn't suit him in that book of his when he talks about the multiverse. And the final point is
catch him out later this evening.
Sorry?
You should catch him out later this evening.
And the final point is...
Dawkins or Rees you're referring to? Oh, Dawkins.
The final point is for the younger members of this community. You may not have read Olaf Stapledon's book Star Maker, but if you want a wonderful book about the multiverse and God, go and read Olaf Stapledon's novel Star Maker.
Joe?
I wanted to make a brief comment along these same lines and then ask a question to Janet. So the brief comment is that the three alternatives, there's a third alternative to God creating the universe and answering all our problems, and the multiverse. First of all, of course, scientists normally reject the God explanation as requiring then an explanation for God, and so it's a very incomplete explanation. There's the regress problem, besides which we like to have physical explanations for physical phenomena. But the hope that I think Einstein had, and which is expressed in this question that Bernard quoted, of the question that really interested Einstein is whether God had any choice in making the universe. And the hope that many people had, and still have actually, in connection with string theory, is string theory has one-dimensional constant in it, effectively. And so all the dimensionless things, like the forces of nature, the things like the fine structure constant that describe electromagnetism and the other corresponding things, which are adjustable in the so-called standard model of particle physics, in string theory should all be predicted if we ever could find the right solution of string theory that would correspond to the sort of world we have. So it might be that there is a unique solution. So I just wanted to mention that that's still a possibility. It has not been ruled out, and I guess George was referring to that when he said lots of people in the string theory community don't believe that the landscape is the story. Now, I wanted to ask Janet a question about this ex nihilo business. I've never really understood why that's important. And I also was puzzled at your remarks about ex nihilo and Judaism. Yes, Philo seems to be moving in that direction, but Philo was a Greek Jew living in Alexandria who had little impact on the Jewish literature. And at least in my reading of the Jewish literature, where you first get a major figure who's totally embraced the ex nihilo view is in Maimonides. And the reasons are complex, and but that's very late. Now you're talking 1,000 years after Philo. And your mention of Job and Psalms and so forth seems to me not relevant to ex nihilo, but what I'd like you to do is maybe elaborate on it, because maybe I've missed the point. At the beginning of Genesis, God is hovering over the waters. It doesn't say God created the waters. God calls into existence all kinds of things, light on the first day, and on the fourth day finally gets around to sun, moon, and stars, and so forth. But the claim is not in Genesis or in Job or in Psalms, as far as I can see, that God is creating those out of nothing. You do get something like that in Maccabees, but Maccabees was Greek. It was written in Greek by Greek Jews. So there you're getting the Greek influence, probably Hesiod and so forth. So the question is, where does this ex nihilo business come from? It's obviously an attempt to glorify God. Certainly Augustine says that. But is it essential? What is its religious role? And if it arises in Judaism, where?
It's definitely not a Hellenistic role unless we say Hellenistic Judaism. It does come out of Hellenistic Judaism. It isn't retained in the rabbis, but we have every reason to believe it was very common amongst Hellenistic Judaism of Philo's time, which is earlier.
And even Maccabees, which is 2 centuries before that.
Maccabees is where you get this first statement. And although Maccabees is written in Greek, impeccable Greek, it's very anti-Hellenistic, and it's a very Jewish work. Because the context is the woman seeing her 7 sons killed, and she said, can God who made everything that is not bring you back from the dead? And that's another thing that's emergent at this period in Judaism, a big debate over resurrection. And as you know, Jews today are split over that. Some Jews, believe in resurrection, some don't. So these things, this is a developing notion which has a bigger footprint in Christianity, but it's very, very interesting. The same elements are there in the rabbis, not put in quite the same way. But it's fascinating that with Maimonides, he uses a lot of the same texts and same arguments as Philo without having any knowledge of Philo, which seems to me to suggest that it is something that's...
But great knowledge of Aristotle.
But great knowledge of Aristotle, but Philo didn't have great knowledge of Aristotle.
No, Philo was really depending on Plato.
In Platonism, that's right, which seems to me that shows that there is something, it is emergent from a certain strand in Jewish thought, not the only strand. Why it's important? Well, I think why I like to keep it there is precisely to keep this distinction between the creation and the universe in mind, and to keep in mind that the theology of creation is mostly about God and God's relationship to Israel and to people. Is not primarily, wasn't devised to think about cosmology. Now we think about those things after the fact. But to avoid forcing the Bible into being something it's not, which is a book of cosmology. But I think, too, this idea of radical transcendence, it's that, to me, is important because it suggests a world in which everything is held in being, intimately held in being by God, but yet God is not a creature in that world. It suggests, if you think 2 things can only be so close together as that, but God can be, as someone said, closer, I think citing the Islamic text, closer to someone than the veins on their own throat. That's made possible. Where there's a philosophical backdrop to that, it's through this kind of thinking. So it's a contemplative strategy, which is also metaphysical, and I think it's very important for warning us away, again, a very deceptive kind of deism that has risen up in the past couple of centuries that makes God into a great big sort of Wizard of Oz sort of fellow who can just, oh, I've got a good idea, let's make a universe, I'll tune it up a bit and get it on the road and puff out a few multiverses. And, I do believe very strongly in a creator God and a personal God and so on, but I don't think that compels me to believe in that kind of anthropomorphism.
Joel, can I just go back to your first point, which of course was a very different one about, okay, maybe it is true that the string theorists will eventually get what they want, the theory gives all the constants uniquely. And as George says, it's certainly not true that all string theorists believe in the string landscape. But if that is the case, you then still have got the miracle that the constants which actually are going to be predicted by this final theory are the ones that satisfy these fine-tunings. And that's always been the reason why some of us have been a little bit dubious about the expectation that there would be a final theory.
Well, the interesting question then is whether it's a miracle. And on that, you can quote Einstein. Einstein said that there are 2 different views on miracles. You can either regard everything as being a miracle or nothing as being a miracle, and he said that his own preference is for the first view.
Yeah, but it all comes down to the question of how unlikely are all these fine-tunings, and of course one can argue about that, but I mean...
The point is that if in fact the laws of nature are such that all these constants of nature, like the fine structure constant, have to have the values that they're measured to have, and that there's no other alternative, then there's no other alternative, and it wasn't a miracle at all. Well, or if you want to, you can think of everything as being a miracle.
Can I just ask a point of clarification among the experts here, because a lot of this is new to me. when you say not all the string theorists believe in a landscape, my understanding, it's a mathematical fact that all these Calabi-Yau spaces exist. That's just mathematics. So if you say they're all they're all consistent with the theory, then there's a landscape. I mean, when you say not everybody believes in a landscape, what is it you're saying?
The issue is, what's relevant for our three-dimensional of space plus one dimension of time world is a particular compactification of string theory. And nobody knows whether any of the string theory versions that people are thinking about admit that compactification. So,
but that's to say the landscape might not even be big enough.
No. The fact that you need to reduce to 4, and how would you reduce precisely to 4?
Right, you reduce to 4, so you have the remaining compactified ones. There are lots and lots of mathematical possibilities for those compactifications, right? I mean, am I just mistaken?
We just don't know if any of them are actually will actually work, are relevant, that they'll actually work for.
But again, that's not to say the landscape doesn't exist. It's to say it's not even big enough.
It's a mathematical structure, but the question, it might be completely irrelevant.
So the final 2 questions before we close, because we really need to head up to dinner. Anyone? Yep.
Yes, I just had one quick comment for Paul, who I believe was asking. I forget who you were asking. There was the comment. Well, if I came across this heap inside a junkyard, but it was a very, very intricately, and it's obviously very unique. Why do I find this? Why do I feel compelled to have a fine tuning for the sake of this creation? I thought. Well, I sort of thought that Bernard might have been missing a little bit of the thrust behind the anthropic principle, which is not to say that the anthropic principle is necessarily correct, but to say that there's a kind of weight behind when you think about exactly what the intelligible whole of human activity is, and this was sort of spoken about yesterday, how you can in one sense see something moving and you can see something persisting through time. But when you see things together, they make an intelligible whole that, whereas it can be obviously reduced to smaller things, there's a kind of necessity for the individual to say that I acknowledge that this is a whole that is made out of parts, not simply parts. And I guess I was just thinking that if you think about the difference between a heap and what we say otherwise, you'd say you don't call the person the heap. What exactly is it that makes the person as opposed to the junk, the heap? If there is really some kind of intellectual whole there that you'd say doesn't require fine-tuning, but at least causes you to ask, why is it like this? Especially when you consider it's not just that it's a this thing, because I suppose you throw a million die, you can get any kind of order you want, maybe a long enough time, but you see that it actually persists in a kind of regular activity. So you say, all right, well, I'm always going to be waking up, doing this, doing this, doing this. I don't know. Do you think that helps at all, or is that any kind of suitable response in your opinion?
If you have a quick response, sure. But
maybe we should leave it for dinner.
Yeah, I think, this can be discussed offline. Is there any other pressing question? Yep.
It seems to me this whole fine-tuning question is far too anthropocentric, because, you could imagine, as science fiction writers have imagined, kinds of life and kinds of consciousness that exist, as energy beings, for example, which don't require, all the kinds of chemicals that make us. So who knows, there might be some parts of the multiverse where there are energy beings cavorting around stars, and very thankful that they don't have the kind of universe where these stars can explode or something.
Well, you do need stars. You mentioned. The point is, you're right that we deliberately try to avoid being too anthropocentric. I mean, the arguments normally given relate to galaxies and stars and chemistry, essentially, and specifically avoid getting to the particulars of even carbon or the sort of things that make us. But I agree, but the point is, whatever your criteria for life, it's likely to require some prerequisites, which will require some fine-tuning. What I'm saying is, if you take any combination of constants at random, you would not be getting any form of life. So if you want our particular form of life, you're restricted very, very narrowly in this space of constants. But obviously, you don't need to be restricted that narrowly. You can broaden the size of the domain of parameters and get some form of life, or maybe you can go to a completely different region of this space and get life. But the assumption is that it's a small filling factor.
Can I just say, I mean, look, taking your cues from science fiction maybe isn't such a great idea. One of the great triumphs, I take it, of Darwin was to show how a certain kind of organized complexity and apparently sort of teleological structure and so on can arise without any planning. But there are preconditions for that sort of explanation. There has to be stability, right? You have to have structures that are stable, that persist through time, that can carry information, that can mutate. You can't make them out of photons, right? If you only had photons around, you can't do it. I mean, maybe a guy writing a science fiction novel can do it, but I honestly don't think that. So I think you don't want to be too parochial. I mean, that's absolutely true, but I do think you could give some probably decent conditions for having the kind of situation, say, where you could have evolution, which are very generic, and you might have a pretty good clue as to what conditions would have to obtain for that.
Okay, at this point, I think we should wrap up, and we should thank everyone at the session for a wonderful afternoon. Just a couple of quick announcements. We're heading up to dinner, and there'll be 2 sets of shuttle buses taking us after dinner at 7:30 and 7:45 to the Whitney Humanities Center for the public talk. So 7:30 and 7:45 upstairs are the 2 shuttle runs. So please proceed upstairs to dinner. Thank you.
Well done. That was very clear.
If anyone's had problems with a bus, please let me know, okay?
I'm just surprised about a historical claim.
Yeah.
So you seem to be saying that the notion of God, as you say, is the guy behind the curtain in the Wizard of Oz who created it.
Yeah. Another quick announcement that we may. We're all going to be seated in the front row. We have reserved seats at the Whitney Humanities Center. And we're going to attempt to take another group photo there. So it would be great if people could just get there a little early and get organized on their seats. Thanks.
I mean, maybe we're back again. All the stories, the Jews believed they were a chosen people. They were chosen by somebody. There was something that, visited 10 plagues on the Pharaoh. I mean, that's a guy. That's exactly the guy behind the curtain.
I'm not saying that. No, it could be. It could be, but there was
based on the fact that someone observing the universe.
Well, it wasn't. There are other ways of explaining
almost
that.
Therefore, assuming at the outset.
And of course, it was exercise which people were bothered with, the anthropomorphism in the scriptures. You have Philo writes excessively about it. So do a lot of the Christian fathers. That you can't take this language literally. They do believe that God performed mighty acts and God liberated the people from Egypt and all this kind of thing. Yes, indeed, but not in the way that it becomes.
So I'm not her universe with,
but there's still there's subtle theologians today. I'm sure there were subtle theologians back then. As a sociological question, which is just a kind of counting noses question.
But
how many people who declared themselves Christians or Jews at any given period would have had a subtle view, as opposed to this rather gross, God's the big guy doing all this?
Tons and tons. I don't know so much in the Jewish material, but we have tons and tons that were delivered to ordinary people, 4th, 5th, 6th, 8th century, that are very sophisticated, and that clearly people were able to, and we can tell because sometimes tells us who he's addressing. He's not necessarily addressing the intelligentsia.